A digital multimeter, DMM, is an essential tool for measuring electrical parameters such as voltage, current, resistance, and more. Unlike its analog counterpart, it uses an electronic display to show readings. Here's an in-depth look at the parts of a digital multimeter and their functions. Parts of a digital multimeter and their functions. 1. LCD LED display. Function: shows numerical readings of the measured values. Features: may include additional indicators like unit VAORAMU, polarity plus or minus, and function mode AC/DC. Some advanced models include a bar graph for analog-like real-time feedback. Past 2. Rotary selector dial, function range selector. Function: selects the type of measurement, voltage, current, resistance, etc., and the desired range. Common settings: AC voltage V or SCLAS, alternating current voltage. DC voltage, V nice or kanked, direct current voltage. Current A, DC current at direct current. AC current A, alternating current. Resistance ohm measures resistance in ohms. Continuity test: emits a beep if a low resistance path exists. Diode test: checks the voltage drop across a diode. Capacitance NF, NuMu F, MF measures capacitance. Frequency Hertz measures signal frequency. Temperature degrees or degrees Fef requires a thermocouple for temperature measurements. Impact: ensures proper mode is selected for accurate and safe measurements. 3. Test leads, probes, function: provide the connection between the multimeter and the device under test. Parts: black lead, used for grounding or the negative connection. Red lead, used for positive input. Input points: common, ground terminal. Voltage resistance continuity input, for measuring voltage, resistance, continuity, capacitance, and diodes. High current input 10 A, dedicated for high current up to 10 A measurements. Low current input milliamps per mA for measuring small currents. #4. Input terminals. Function: connect test leads to the multimeter based on the measurement type. Terminals usually include COM terminal, common ground for all measurements. VOHz terminal, for voltage, resistance, frequency, and continuity tests. MA for MEMRU A terminal, for low current measurements. 10A terminal, for high current measurements. 5. Buttons, mode selector, and other controls. Function: additional functions for customization and measurement refinement. Common buttons: hold, freezes the current reading on the display. Range: toggles between auto and manual ranging. Relative, measures relative differences by subtracting an initial value. Mode: switches between AC/DC or diode continuity modes. Max-min: captures and displays the maximum and minimum readings. 6. Continuity beeper. Function: produces an audible beep when a circuit has low resistance, indicating continuity. Useful for quickly identifying broken circuits. 7. Internal battery. Function: powers the multimeter's digital circuitry. Maintenance: replace the battery when the low battery indicator appears. 8. Protective fuse. Function: protects the multimeter from overcurrent damage. Commonly found near the current measurement input terminals. Function: protective case, shields the multimeter from impacts. Kickstand: props the multimeter up for hands-free viewing. Functions of settings. 1. Voltage measurement, AC/DC. Select the V mode, AC or DC. Use the red probe in the V1 terminal and black probe in the COM terminal. Connect the probes across the circuit component. Read the voltage value on the display. 2. Current measurement. Select the A mode, AC or DC. Insert probes into the appropriate terminals, May or 10/8, based on expected current. Place the multimeter in series with the circuit. Display shows the current value. Resistance measurement. Select the All mode. Connect the probes across the component. Ensure the circuit power is off for accuracy. Display shows the resistance in ohms. 4. Continuity test. Select the continuity mode, often indicated by a diode symbol with a sound icon. Connect probes across the circuit component. Listen for a beep if continuity is present. 5. Diode testing. Select the diode mode, triangle pointing to a line symbol. Connect probes across the diode, red to anode, black to cathode. Display shows the forward voltage drop, or OL, if reverse biased. 6. Frequency measurement. Set to the frequency mode Hertz. Connect probes to the circuit. The display shows the frequency in Hertz. 7. Capacitance measurement. Select the capacitance mode, symbolized by mas. Insert the capacitor leads into the corresponding slots or use probes. Wait for a stable reading. 8. Auto versus manual ranging. Auto range automatically selects the appropriate range for the measurement. Manual range. User selects the range using the range button for more precise control. Hop 9. Relative mode, REL, measures the difference from a preset reference value. Tips for proper use. 1. Range selection. Start with a higher range to prevent damage, then adjust for accuracy. 2. Polarity check. Observe proper polarity, especially in DC measurements. 3. Probes handling. Keep probes clean and undamaged for accurate results. 4. Safety first. Avoid exceeding the multimeter's ratings to prevent accidents. 5. Fuse maintenance. Replace fuses promptly if they blow. Understanding these parts and their functions ensures efficient and safe operation of a digital multimeter in various electrical tasks.